I forgot to mention that I did not discover this trick on my own. I got it from the webpage The Accountant, run by Imke Feldman on this specific page where she shows the method. So you can go to that page in the description in order to read this page for yourself if you want to. Yep. In this video, I'll be going over how to use metadata in order to store certain informations in your table. In this case, I have a simple table where I want to apply a filter on the name column. Then I apply various filters on my day column. I want to know how many rows did I have at the beginning after applying a filter on the name column, after filtering on year, on the previous 90 days, and in the previous month. In other words, just count the rows of a bunch of steps. But I want to print this step as my actual table that I'll then load into Power BI. My problem is that I can't just make a new query where I reference query 1, this specific step. So for instance, only Denji. I can't do something like going in and say I want to access query 1, but I don't want to access the last step. I want to reference a specific step. So for instance, only Denji, that step. The square bracket refers to the column, so I can't do that. But I also can't refer to the step by name, only Denji, because it doesn't know what this means. So I need to access the step only Denji from query 1, which I can't do. And that makes sense when you go into Advanced Editor and see how are these steps actually translated into a table. Because this let in syntax is like with variables, because it is the exact same syntax. These steps, the individual steps, are variables that are actually ignored. They aren't relevant. They're only used in order to produce the actual step that gets printed, which means I can't access them from query 2 because they effectively don't exist. Their only purpose is to create the current month step, which is why I have access to that step when I reference query 1, because query 1 is then equal to the current month step because that's the step that gets printed. So I need a way to access these steps in my last step. And that's where the meta keyword comes in. If I first add a new step where I want to count the rows, where I'm going to cheat and use my notes, I now count my change type step, and I can see that I only removed one row when I filtered on person, and I have a few rows outside of the current year. And of course, I only have one row per day, so this is expected. But of course, if this was something like a sales table, you would have varying rows. You could then decide whether you actually want to show the actual number. If you want to say 441 minus 366, so that's how many rows you remove, that would be a slightly different calculation. But that's not what I'm interested in this case. I now have this step, but now if I print this, query 1 would equal this record, and that's not what I want. I do want to print this current month step. I'm going to have my second to last step be row count, and my last step refers to current month. And I don't technically need this. I could have my current month step be the last step, and then row count, I can move that up between here because I'm allowed to reference a step that comes after the current position. These steps don't actually have to be chronological, but that makes more sense for the user to read it. I can have row count here, but it's just silly. You can see how the code updates automatically. I want this record to be printed, so I want to be able to access this step outside of the query itself. And it's very simple to do. It's writing the keyword meta, and this will add this as meta information, so information that's sort of hidden in the background. And all I want to say is I want to pass in a record, which is just the syntax you have to use, because again, you have to refer to it by name somehow. And a record means I can say that this should be called row count, which is then equal to the step row count with a space. And nothing has changed, at least not visually, because again, meta means it's hidden in the background. But this means that when I print this table, this step, which isn't referenced in the code, that's now suddenly referenced, but it's just referenced in the background, which means normally this step wouldn't be calculated because it isn't used in the final step that gets printed. And because Power Query is a lazy evaluator, it skips any step not referenced. That means when I update this query, because I'm going into the individual steps and calculating the rows, it will take longer to update, and especially if you have a larger data set. I can see it messed up with references here. Yeah, and I didn't want to print that. That was because I swapped the order around. I didn't expect it to make any difference. If I go into query 2, but I want to reference the metadata of query 1, and I do that by typing in metadata, and I'll get, if I knew how to spell, I would get value metadata. Remove metadata and replace aren't relevant right here. I simply need to access the metadata. So I type in the name of my query and I get a record that has all of my metadata. So I have query folding and you can see that field isn't found, which is expected because I'm not accessing a SQL server where I can do query folding. I can see this row count key, which I then access like normal with a square bracket. Say I want to extract row count, which then gives me the same step as I had before. So now I have my query, which gives me my actual table, and another query, which extracts a specific step. And I'll mention it again. This is going to make my query take longer to update because now I do have to access each step and count how many rows there are, which wouldn't be necessary. You can especially see that in this query because of something called query streaming, which means that in my last step, I'm applying a filter that says I only want the rows that exist in the current month, which is the most restrictive filter I have. In this step, I'm saying go into the previous 90 days table, but I don't want to return all of those rows. I only want those rows where this operation evaluates to true. So any row inside of my 90 days table, which is not in the current month, will be discarded. But this table also refers to the current year table, which means that any row in the current year's table will be removed if it isn't found in the most recent 90 days. But this table has also ultimately been filtered to the current month. So if I ran this query like normal, it would be much faster because I know I don't have to include this row, the 1st of January of the current year, because that won't be found in the current month. So I'm not storing this table temporarily because I only need the rows in the current month that are equal to or less than today, which are these 6 rows. But because I now have this row count step, which requires me to access every single row of this table, I now have to materialize that table in order to calculate that, which is going to be more expensive. So you can decide whether this is necessary. If this is information your user needs on a regular basis, then adding this metadata and printing it, that makes sense. But if it's only something for internal use, like when I go in and I check whether this makes sense, like if I expect there to be 40,000 rows, expect maybe 1,000 rows here, I can check if this is true. If I only need to know that as sort of a diagnostic tools, then I wouldn't reference it in the query. That is in the last step, just because there's no point in maybe spending an extra 2 minutes calculating this and printing it unless I need to show it. But in my specific work case, my user needed to know how the table gets filtered because they maybe need to know how many rows are removed when we remove deceased people because we can't ask them to pay their bills. In any case, that was how to do it. In the last step, add meta and then a record with a name and then the step you want to save and then value.metadata, name of the query, square bracket, name of the key. So, yep,